Hello, Algebra 2A, and welcome to Lesson 1, where we're going to use properties of real numbers. Our learning target today is to classify numbers according to which subset of real numbers they belong and identify and apply the real number properties. First, we'll talk about the first half of our learning target, classifying numbers. All the numbers that we work with are called real numbers, and within real numbers they're split into two subsets: rational, which comes from the word ratio, so numbers that can be written as a ratio or a fraction, and then irrational, not rational, which cannot be written as fractions or ratios. Then within rational numbers, we have whole numbers, all positive counting numbers, so the numbers you learned counting, 1, 2, 3, 4, and so on, and integers, which include the counting numbers and their opposites, so -1, -2, -3, and so on. Examples of rational numbers can be found over here, as well as examples of irrational. So our most popular irrational number would probably be pi, 3.1415926, so on and so forth. Does not repeat, does not terminate. Another example of an irrational number is any number that is a square root of a non-perfect square. So square root of 50 would be 7 point something something something, and it would continue without end. Whereas square root of 49 would be 7, which would be rational. So examples of rational numbers are any square roots of perfect squares would give us a nice rational number. We will start with our first learning target, identifying subsets of real numbers. If irrational, we will explain our answer. So first we have -16. So anytime we have a number by itself, we could always put it over 1, and then it would make it a rational or a fractional number. So it is rational. Next, -16 isn't the numbers we count, but it is an opposite of a number we count, so that would make it an integer. And then it is not a whole number because it is not one of our counting numbers. Secondly, 32. 32 could be placed over 1 to make it a fraction, rational. It is one of our counting numbers, so it's an integer, because integers are counting numbers and their opposites. And then it would also be considered a whole number because it is included as one of those counting numbers. For square root of 20, I want to just take a look at my calculator. If I put in square root of 20, in this case it is square root of -20, that's all right, just makes it negative. I do get a number 4.472135955, and it looks like there's not really a pattern that repeats, and it's not going to end. So any number that you take a square root that is not a perfect square, that does make it irrational. So irrational numbers are those numbers that do not repeat, do not terminate. So this one would be irrational, and then I do need to explain my answer. My answer is this one is a non-perfect square. So any non-perfect squares will always be irrational. Okay, and lastly, square root of 49, since that is 7, that's going to make it rational. That's also going to make it an integer. And lastly, since 7 is a counting number, that is going to make it whole. Second learning target we're taking a look at today is looking at the properties of addition and multiplication. Our first property is the commutative property. Commutative property of addition says that if you add a plus b, it's equivalent to b plus a. You can add those in either order. Same with multiplying. A times b is equal to b times a. Associative property says that if you add a plus b first and then add a third number c, or if you add b plus c first and then go back and add a third number a, that is going to be equivalent. So if you have 3 or more numbers, you can decide any order to add those up. And same with multiplying. If you have a times b and then multiply it by c, it would be equivalent to taking b times c first and then multiplying it by a. And lastly, we have distributive property. So distributive property involves both addition and multiplication. I can take a times b and then go back and take a times c, and the sum of those two products, a times b plus a times c, is going to be equivalent. So that a is going to be what's in common in both of those products. That's the number that was distributed. Let's taking a look at identifying a couple properties. In our first example, A, 23 plus 10 is equal to 10 plus 23. Since I am changing the order with addition, this would be the commutative property of addition. Part B, I have a 1/4 times 1/3, and then I'm adding to that a 1/4 times 2/5. Now, when we see the parentheses, we might think of associative property, but another thing that's jumping out is there is a common 1/4, and then that's equivalent to 1/4 times the sum of 1/3 plus 2/5. Since that 1/4 is in common, this is going to be the distributive property. And lastly, I have -3 times 7 times -5. And these are treated like parentheses, these little brackets here. So the parentheses right now, as I look at it, around the 7 and the -5. Now I move those parentheses to around this product, -3 times 7. So when I change the parentheses from grouping 7 and -5 together to now -3 and 7 together, I am using the associative property because I'm deciding to multiply them in a different order. This would be the associative property. And then whatever operation I'm using, which is multiplication, that's the type of property it is. So associative property of multiplication. Checking out problem 3, we're going to simplify each expression and then identify which property we used. So our first one, we just want to add up some decimal values. So maybe we went to the store and we bought some items for these prices. It might be kind of hard to add up in this order. So if I move the 8.5 over, so the 8.5 and the 2.5 would be next to each other. 0.5 and 0.5 would be pretty easy to add up, and then 0.3 and 0.7 are also compatible numbers, which will add up to the nearest dollar. So I'm going to use the commutative property of addition. And so now I'm going to have 2.5 plus 4.3, 2.5 plus, let's erase that, 2.5 plus 8.5 plus 4.3 plus 1.7. Now I've got my compatible numbers, so 50 cents and 50 cents would round up to $1. So maybe this 50 cents goes over to here and makes it $3. 3 plus 8 becomes 11. Plus 70 cents and 30 cents make $1, so this would be 5 plus $1 would be 6. Now I've got a total of $17. So I could use that commutative property of addition to move the order and get those compatible numbers together. Secondly, we're trying to multiply 24 times 5 and 3/4. So maybe we have pieces of wood that are 5 and 3/4 in length, and we want to find what would the length of 24 of those be. And multiplying 24 times 5 and 3/4 strictly together would be a little bit tough. So we're going to use the distributive property to help us out. So 24 times 5 and 3/4 can be thought of as 24 times 5. And then also, since we have an extra 3/4, we're going to multiply 24 times 3/4 and then add those two together. So over here we have the math on the right there. So 24 times 10 would be 240, just adding a 0. Well, 5 is half of 10, so 24 times 5 is going to be 120. Then we have 3/4 of 24. 24 broken up into fourths is 6. 3 6s make 18. So we're going to have a total of 138. And that's just a quick way to mentally multiply numbers together. We can break up 5 and 3/4 to 5 plus 3/4 and then start to use the distributive property to multiply those individually. Continuing our learning target of properties, we will take a look at the last two properties, identity property and inverse. Identity just means that a number using adding or multiplying keeps its same value. So when adding to keep a number the same, you can add 0 to it. A plus 0 equals A. When multiplying to keep a number its same identity, you can multiply it by 1. A times 1 is equal to A. Secondly, we have inverses of adding and inverses of multiplying. The inverse for adding are the opposites. So you're trying to add to 0. A plus -A is going to equal 0. And that's going to be true for any number. So if you take 100 plus a negative 100, that's going to even out to make 0. Another way we can think of this property is that we are just talking about the numbers that are opposites as far as their sign, plus and minus. And with multiplication, we can take a times its reciprocal 1 over a, and that's always going to be equivalent to 1. So inverse for multiplication are representing the reciprocals. So we will now take a look at example 4 and practice those two ideas. So first, when I'm looking for the additive inverse of 3 minus d, I am looking for the opposite of 3 minus d. And I'm going to put then a negative out in front of 3 minus d. Now this negative can be treated like a negative 1. It's going to make both these numbers in here their opposites. So negative to the 3 is going to make negative 3, and then a negative to that negative d is going to make that positive. So we could have negative 3 plus d, or using the commutative property, we could rearrange those. That could also be thought of as d minus 3. So there would be our additive inverse of 3 minus d is d minus 3. When looking at a multiplicative inverse, we are looking for the reciprocal of the given value. So we got 2 over y plus 5. To find the reciprocal, we just interchange the numerator and denominator. So y plus 5 in my inverse is going to be in the numerator over 2. So there would be my multiplicative inverse. Finally, we are going to multiply out a recipe. So it says Sharona uses 1 1/3 pounds of grapes to make 1 jar of grape jelly. She is making 12 jars for friends. Use the distributive property to calculate the amount of pounds of grapes she needs. So basically, we are going to take 12 times 1 1/3, but we are going to think of 1 1/3 as 1 plus another 1/3. So we're going to figure out how many pounds we need, or how many jars for this 1 pound, and then how many for the 1/3. So we'll take 12, we'll distribute that out. So first we'll take our 12 jars times the 1 pound, because we do need a pound in each jar, and then we do need that extra 1/3, so we'll take our 12 times that additional 1/3. So we're thinking of 1 1/3 as two separate values. 12 times 1 is going to multiply to 12. 1/3 of 12, break 12 down into threes, that's going to be 4, and only one of them would be 4. So all in all, to make her jam, she is going to need 16 pounds of jelly, of grapes. So we have covered both of our learning targets. So we looked at first classifying numbers, and then secondly looking at the properties of real numbers. So now you're ready for your practice, and we'll see you next time.